Welcome to 7.3. Thank you for joining me. Today we are going to be talking about multiplying powers with the same bases. So before I give you the rule for this, I wanted to do a little discovery of our own. So x squared times x cubed. So when we multiply this out, well, x squared is x times x. X to the third is x times x times x. So I want us to think about how many x's are we multiplying together now. Well, total, it looks like we're multiplying 5 of them. So in the end, this expression should give us x to the 5th. Let's do the same thing with those 5s and see if we can see a relationship. 5 to the 4 would represent 5 being multiplied out 4 times. 5 to the 5 would represent 5 being multiplied 5 times. Well, now, if you count up, how many times is that 5 being multiplied? I said being multiplied 9 times. 5 to the 9. So, what I want us to notice and see is notice we had 2 and 3. That gave us 5. We had 4 and 5, and that gave us 9. So when we're multiplying with the same base, I want you to notice all we're doing is adding the exponents together. That's actually all we have to know. Now, do realize the bases must be the same, okay? So in this example down here, 2 times 3 squared. We can't do anything with that. The 2 and the 3 aren't compatible, so we just have to leave that 2 times 3 squared. There's nothing we can do using our rule for that, okay? The bases have to be the same. So, when you multiply powers with the same base, you simply add the powers. All right? So that's going to be the main point of today. When you are multiplying two things with the same base, all you have to do, add the exponents together, add the powers together. So looking at our next example, 2 to the 3 times 2 to the 5. So our bases are the same. They're both 2. So all we have to do is add the powers together. 3 plus 5 gives us 8. X to the 3 times x to the negative 5. Again, here we're dealing with the same base. Both are x's. So 3 plus negative 5 gives us negative 2. This one we can actually take a step further because we talked about not liking negative exponents. So this one we could take one step further and even call this 1 over x squared, wrapping in those skills from 7.1. But again, the main goal here, I want you to see you are adding those exponents together. Some common errors to avoid, all right? So here, 4 squared times 4 cubed. So we have that like base, that 4. Add the exponents together. 2 plus 3 gives us 5. What I want to make sure you do not actually do 4 times 4. Do not tell me 16. You don't change the base whatsoever, okay? That 4 stays the same even in the solution, okay? So don't fall for that mistake. The base stays the same. It's the exponents you add together. Next thing, don't leave negative exponents in your answer, okay? So don't leave this 2x to the negative 3. That x to the negative 3, you have to move to the bottom, okay? Where it can have a positive exponent, an x to the 3 downstairs. That 2 does not have a negative exponent, so the 2 can stay where it is. But because the x has a negative 3 exponent, move it downstairs, move it to the denominator. And finally, don't add coefficients. A lot of students will try to add coefficients together. Please don't do that. What I'm talking about is this 2 and this 3 out front. This is a multiplication problem. So you need to actually multiply those numbers together. 2 times 3 gives you 6. Now you look and say, oh, okay, I have those x's. X and x. This is an x to the first, x to the 1 power, x to the negative 4. So 1 plus negative 4 gives us x to the negative 3. And now, just like what we did before, we have a negative exponent. We don't want to leave it that way. So that x to the negative 3 moves downstairs. But that 6 does not have a negative exponent. So that 6 stays exactly where it is. And that is how we'd write our final answer. All right, so now, just to get some more practice, a feel for what's going on here, we're going to step through quite a few examples to make sure you are understanding what is going on. So, m to the 3 times m to the 4. We have that like base. So we have m, and now we add the exponents together. 3 plus 4 gives us 7. So simply it becomes m to the 7. T to the negative 5 and t. Well, that t is just a t to the 1. So we have our common base. So t, negative 5 plus 1 gives us a negative 4. Now again, we can't just leave it like this. This is not our final answer because we have a negative exponent. We have to take that t and put it in the denominator where it can have a positive exponent. And now because there's nothing left up on top, we throw a 1. All right, our next example. So here again, when there's no exponent written, it's assumed to be 1. So we have that negative 2. And now we have 1 plus 3 plus negative 7. Or 1 plus 3 gives us 4. 4 minus 7 leaves us with a negative 3. So now, again, we can't leave a negative exponent, so we have to send that to the denominator. So 1 over negative 2 now to the positive 3. Now, you could leave it like that, but again, to make it as simplified as possible, we can actually calculate out negative 2 to the 3 power. When you do, you will see that is negative 8. So that is a final answer I would like to see. All right, we need to finish writing. Pause the video, finish writing up this slide. Otherwise, we are going to continue. Now, I told you, unfortunately, this is going to be just a lot of practice. Repetition, so you begin to understand these rules, okay? So z to the 8 times z to the 5. Again, we have z and z, and we're going to add our exponents. 8 plus 5 gives us 13. All right, now, number 2, this is getting back to what I was talking about before. When you have coefficients, so here we have a negative 4 and a 6 that are also being multiplied. When you have those coefficients, the first thing you should do is multiply those together. You get negative 24. Now, focus on the exponents. K to the negative 3, k to the negative 4. Negative 3 plus 4 gives you a k to the 1. And don't forget, you don't have to actually write that 1. So you can just call that negative 24k. Same thing with this next one. The first thing you should do is the coefficients. So you have 13, you have 3. Well, 13 times 3 gives you 39. Now, focus on the exponents. X to the negative 8, x to the 10. Negative 8 plus 10 gives us a 2. So that is going to be our final answer. For this next one, again, deal with the coefficients. Negative 2 times 4 gives us negative 8. H to the 5, h to the negative 3. Add the exponents. 5 plus negative 3 leaves us an h squared. When you're looking at your next one, we have t. All right, so 3 plus 9, or 3 plus 6 gives us 9. Plus 9 gives us 18. So altogether, those give us a t to the 18. All right, so here again, we need to deal with the coefficients first for number 6. Now that negative out front, consider that a negative 1. All right, so we're dealing with coefficients. We have negative 1 and 4, giving us negative 4. Then we have f to the negative 8, f to the 12. Negative 8 plus 12 gives us an exponent of 4. So these, again, I know it's kind of Joe and killer right now, but with repetition, you will see these patterns and how these problems really aren't too terribly difficult. Now, you can also do this when you have more than one variable. So first, for number 7, I'm going to identify. I'm going to focus on my m's first, okay? So here we have an m to the first, m squared, and an m to the first. 1 plus 2 plus 1. That's going to give us 4 m's. Next, I'm going to focus on the n's. N squared, n to the negative 4, n to the negative 1. So, 2 minus 4 minus 1 gives us a negative 3. Now again, remember, we don't want to leave it as a negative exponent, so I'm going to take that n to the negative 3, move that to the denominator where it can have a positive exponent. Always looking for positive exponents. All right, number 8. We have 6 and negative 4 as our coefficients. Those are going to multiply to give us negative 24. Next, I'm going to focus on the a's. I have an a to the 3 here, a here, which we know means a to the 1. So 3 plus 1 gives us an a to the 4. B to the negative 2, b to the negative 8. So negative 2 plus negative 8 is going to give us negative 10. So, looking at this, we have something with a negative exponent. I'm going to get rid of that, okay? So, the negative 24 can stay. The a to the 4 can stay. But that b to the negative 10, we're going to move that down to the denominator where it can have a positive exponent. All right, number 9. Q to the 4, Q to the 3. That gives us Q to the 7. Then R to the 5, or R to the negative 5, R to the 5, negative 5 plus 5 gives us an R to the 0. And we know anything to the 0 power is 1. So all we're left with here is Q to the 7. All right, I'm going to cut off our video here. So, thank you for watching this video. We are going to wrap it up in class tomorrow. So again, thank you for watching, and we will finish up these notes together tomorrow.